Sludge is worldwide the most used suspended growth process in wastewater treatment. The treatment process can include different steps, but most commonly are screening and grit removal to filter out debris, primary clarifier for particle sedimentation, biological treatment with activated sludge consisting of an aeration basin, secondary clarifier and recycle stream, disinfection for final removal of germs and bacteria. Wastewater entering the aeration basin still contains organic matter such as food waste and fecal. Microorganisms in the raw water influent will colonize in the aeration tank and metabolize organic waste to ATP for further cell growth, as well as CO2 and water. As the microorganisms need oxygen to survive, the tank is aerated, for example, with diffuser systems. The amount of oxygen needed for biochemical processes is also known as the BOD value. BOD is a very important indicator for the level of wastewater pollution. To keep a good balance between the number of microorganisms, organic waste and oxygen, some microorganisms are settled down in the secondary clarifier. Adding flocculants will cause that microorganisms will clump together with particles and settle down as activated sludge. Some of the activated sludge is then recycled back to the aeration basin, whereas the rest is removed as waste sludge, thickened and then, for example, used as fertilizers. By recycling the activated sludge back into the aeration basin, the amount of microorganisms can be increased significantly, e.g. 30 times compared to the raw water influent. This is exactly the principle of activated sludge, to accelerate biological degradation significantly in a confined space. The sludge recycling rate does not only affect the sludge volume, but also the sludge age. Young sludge, 2 to 8 days, refers to microorganisms that metabolize organic waste as described before. Instead, older sludge, older than 8 days, is used for nitrification processes to oxidize ammonium, NH4+, to nitrate, NO3-. The sludge age can also be expressed as the SRT, solid retention time. The SRT is the volume of the reactor multiplied with the concentration of solids divided by the excess sludge. The number of microorganisms present in the aeration basin, and therefore the treatment capacity of an activated sludge plant, is limited. The ratio of microorganisms and waste stream is also known as the MLSS, mixed liquor suspended solids concentration. As higher the MLSS, as less volume is needed to remove BOD from the waste stream. The maximum MLSS concentration for activated sludge basins is about 3,500 milligrams per litre. However, by adding fixed film media into the aeration basin, also known as IFAS systems, the MLSS can be increased by up to 5,000 milligrams per litre, meaning the treatment performance can be increased by up to 50%. Please click on the following video link to see in detail how the activated sludge process can be upgraded with fixed film media systems.